I'm gonna record that. All right, guys. So here's the first part of the free body diagram um, exercise. So you click here, and it's going to take you to this interactive. And your goal is to get all these stars here. I got one already. Let's get another one. So remember there. Oh, look, it's another football one. This one's very easy. Let's go back. I'll do a harder one. A rightward force is applied to a dresser to accelerate it to the right across the bedroom floor. Ignore air resistance. Okay, so this is a dresser. The first thing is to draw the outline. Step number 2 is to always put the force of gravity. Every object that exists that has matter is going to have a force of gravity going straight down, right? So that will always be the same on all of these. Someone's applying a force to the right. And then if anything is on the ground and moving in any direction, there's going to be a force of friction going in the opposite direction. So to the left, you're going to have a force of friction. And it's accelerating to the right. So that means this arrow is going to be larger. So it can be larger or smaller. If they're equal, this thing's not going to move. So he's moving to the right, so the arrow will be bigger. And then he's on the ground. So far, these forces are not balanced. This is telling me that this thing is accelerating downwards, but it's not, right? Because it's on the floor. So that means we're going to have an upward force, the normal force. So now these are balanced. It's not moving up or down. It's moving to the right. Congratulations, I did it correctly. So now I have these stars. So I would take a screenshot and I would put that in here. And then you have a few more questions in here. It's drawing the free body diagram and then finding the net force. Let's do this one. 2 lifeguards pull on ropes attached to a raft. One lifeguard pulls to the right with 114 newtons, and the other pulls to the left with 220 newtons of force. So left 220, right 114. And in which direction and with what force will the raft move? Let's draw the free body diagram. And then you guys can find the net force. See, 2 lifeguards are pulling on this thing. So you have some type of boat, a raft. And one lifeguard is pulling to the right with 114 newtons. And the other one is pulling to the left. Why are they fighting? I don't know. $220 newtons of force to the left. In which direction and with what force will the raft move? So which direction is it going to move? If he's pulling with 220 and this one's pulling to 114, it's going to move to the left, right? So you have to find the net force. So that means you just add them up, right? Just add them up. So net force, I'll start it for you, is equal to, let's call this F1 and F2. Remember, to the right is positive, to the left is negative. Force 1 plus force 2. So F net equals what? So that's basically what you have to do. You have to draw a picture, draw the free body diagram. So what's interesting about this problem is that there's also an up and down, right? But it's on the ground. So the normal force and the force of gravity are equal, but they're not asking you about that. They're asking you about these. So don't worry about the up and down on this one. And that's it. I wanted to work on this one actually. Find the missing force C. The whole thing's together. So it says there's 200 newtons going down, but the net force is a positive 900. I see. Okay. Here, I'll set this one up for you guys. Insert. Drawing. So it said that, so I choose scribble and I start drawing. So it said that the net force was 900 up. 900 newtons. But it has a downward 200. So they want to know what is C. So remember F net equals C minus 200. So I want you guys to get, what is C equal to? You have to rearrange. So you got to finish that up. Well, guys, that's all I have for you right now. I'm going to stop recording.